Exponential functions, like any other functions, for you to understand functions, you need to know these two most important things. The first being how to find an equation of a function, and secondly, how to plot a function. So in this video, we're going to look at exponential functions, and then all exponential functions are given with this general equation, which is equals to y equals to ab to the power of x plus q. So in this equation here, we need to know the purpose of a, b, and q. So before we can understand the purpose of a, b, and q, let me just, for example, plot what? A typical graph of exponential function. So exponential function is a function that looks like this, okay? It increases or decreases exponentially. So now, the value of a, if the value of a is positive, that means if the value of a is greater than 0, our graph is going to be on top of the asymptote. We are going to assume that our asymptote here is the x-axis. So do you see now, if the value of a is positive, this will mean that our graph is going to be on top of what? Of the asymptote. But now, if the value of a is less than 0, our graph is going to be below the asymptote. For example, it will be a function like this. So if our function is below the asymptote, this means that the value of a is less than 0. That means the value of a is negative. But now, what does the value of b represent? So now, if we look at the value of b, the value of b, it is actually restricted. So now, the value of b is always greater than 0. That means now you can never have a b that is negative. A negative value just indicates now the value of a. So the value of b will always be positive, okay? But also, the value of b can never be equals to 1. So these are two restrictions of the value of b. So now this value of b, it will represent for us if ever our function is an increasing function or a decreasing function. So let's say, for example, if the value of b is greater than 1, this will mean that we're going to have an increasing function. So if I can plot here, our function will be something like this. So if we move from left to right, our values of our function is going to increase, because now if the value of b is greater than 1, we have an increasing function. So an increasing function is something that looks like this. So as we move from left to right, the values of the functions are increasing. But now, secondly, if the value of b is in between 0 and 1, this will mean that our function is going to be a decreasing function. So this means now as we move from left to right, the values of the functions are going to decrease. So it's going to be something like this. Okay, so the blue line here, it represents a decreasing function. So you're going to have a decreasing function if the value of b are in between what? 0 and 1. And then also, this red function here, it represents an increasing function, and we can only have an increasing function if the value of b is greater than 1. So lastly, what we need to understand here is the value of q. So like in hyperbolic function, the value of q, it represents now the y asymptote. So that means now it is whereby our function is not going to touch. So in this exponential function, we only have what? One asymptote, which is the y asymptote. And then this y asymptote is always equals to the value of q. So I know all this information that I've said is very much difficult to understand, but you don't necessarily need to understand it completely for you to be able to draw your graph, or for you to be able to take the equation from the graph. Okay, so let's say, for example, now we are having this function here to plot. We have y equals to negative 2 to the power of x plus 4. So like any other functions, if we want to plot a function, we need to find first the asymptote, if it has the asymptote, and then we have to find what? The x and the y intercept. So in this case, we know that our asymptote of what? Of an exponential function is what? Is whereby we know that the value of y equals to q. But in this case, the value of q is just 4 here. So our asymptote is going to be what? Y equals to 4. So this is the equation of our asymptote, okay? So after we find our asymptote, we can then find the x and the y intercept. But remember we said now, for x-intercept, the values of y equals to 0. So now, if we want to find the x-intercept here, we're going to say now our equation is y equals to negative 2 to the power of x plus 4. Okay? So we're going to put now where we see y, we are going to put 0 because we are looking for the x-intercept. So this is going to be 0 equals to negative 2 to the power of x plus 4. So now if we want to solve for x, we are going to move this 4 to the other side, and then it's going to be negative 4 equals to negative 2 to the power of x. Okay? So we can divide both sides by negative 1. And then we are going to have what? 4 equals to 2 to the power of x. So remember now, if you have something like this, especially for exponential function, you need to do what? You need to write this in its exponential form. So for example, 4 can be written as what? As 2 to the power of 2 equals to 2 to the power of x. Okay? So for the same base, when we equate the same base, that means now we can drop the base and then equate the exponent. So we will find that the value of x is just equals to 2 here. So but remember now, this x is what? Is the x-intercept. So the coordinate of it is going to be 2 is to 0. So now if we want to find what? If we want to find the y-intercept, what are we going to do? We're going to say what? Y-intercept, we know the value of x equals to 0. So remember our equation is y equals to negative 2 to the power of x plus 4. So but now remember, where we see x, we are going to put 0. So we're just going to say y equals to negative 2 to the power of 0 plus 4. Okay? Please put this in your calculator. Don't assume that negative 2 to the power of 0 is just going to be 0, né? Because any number raised to 0 is going to be 1. So if you put that in your calculator, you will find that the answer that you get is going to be what? Is going to be negative 1. Okay? So you will see that you're going to say y equals to negative 1 plus 4. Okay? You put everything into the calculator because now any number raised to the power of 0 is not going to be 0. It's going to be 1. So just put everything into the calculator so that you can be sure of what the answer is. So now we're going to get now the value of y to be how much? Negative 1 plus 4 is going to give us positive 3. So now our y-intercept is going to be what? Where x is 0, the value of y is 3. So now with all this information that we have, we can be able to what? To plot our graph. So remember now our graph will have what? X-axis and y-axis. So if we plot our graph here, we need to first put what? The asymptote. So remember now our asymptote is here. Our asymptote is where y equals to 4. So we're going to go now on our graph. We say y equals to 4 here. That means our function is not going to touch this line of y here. Okay, that is the asymptote. Remember, the asymptote is where the function does not exist. And then now we can plot our intercept. So now remember, x is just 2 here. So you can just assume now this point here will represent 2 here. And then now y is what? Y is positive 3. So if y is positive 3, that means it's just going to be below here. So it's going to be 3 there. So now you must join your points so that you can have your exponential function. So your exponential function is just going to move like this. Okay, so that is how you will plot your exponential function. So look at this. Remember now when you do the analysis, you're going to look at what? The value of a. So in this function now, the value of a is just negative. So that means it's less than 0. We know if the value of a is negative, our graph is going to be below the asymptote. That is why we see now our graph is below the what? The asymptote, because the value of a is less than 0. Okay? But now if we look at this 2 here, remember, it represents the value of b. So but now what does the value of b do if it is greater than 1? If the value of b is bigger than 1, that means we're going to have an increasing function. So first, how do we see an increasing function? You're going to look at it at the top. Remember, an increasing function is a function that when we move from left to right, it increases. Okay, so this is what makes the value of b to be greater than 1, an increasing function. But now, because the value of a is negative, then we're going to say take this graph and then just do a reflection of it, of which is going to be this graph here. So this graph here, it was originally an increasing function, but because the value of a is negative, when we put it down, we reflect it to this part here, it becomes a decreasing function. But originally, remember, at the top, the value of b is greater than 1, so our graph is an increasing function. But now, because the value of a is less than 0, we deflect it. We're going to put it what? Below the asymptote. So that is why now we can clearly see now our graph is what? Is a decreasing function now as our original graph. Okay, so this is very much complicated to understand, but I will make another video whereby I just clearly explain the function of b and a. Okay, so with all that being said, we can also learn now how to actually find an equation of a function if we are given a function. So let's say, for example, now we have to now find the equation from this function. We have the x exists, y exists, and then they say now we have this asymptote here. We can just assume it to be -2, and then our function is something like this. Okay, so remember, like any other functions, for us to be able to find the equation of this function, we need this what? This asymptote here, and then we also need one point on the function. Okay, for example, they can give us this x asymptote here to say now this point here is what? Is just maybe 3 here. But remember, if that point is 3, the coordinate is what? Is 3 is to 0, because that is the x asymptote, x axis, I mean. Okay, so we are given what? The asymptote, and then we are given one point of the function. So we are able to what? To find the equation of the function. So remember now, when we find the equation of the function, we just write the general equation. So our general equation is just what? Y equals to a b to the power of x plus q. Okay, so now the value of a here in this case, we can just represent it as a sign, a positive or a negative. So looking at our function, we can see now our function is what? Is on top of what? Of our asymptote. So this means the value of a is just going to be positive. So we can clearly have what? Y equals to b to the power of x plus q. Okay, so most of the time when you find this equation from the function, you are not going to have to put this value of a here, because this value of a, it only represents if the graph is positive or negative. Okay, so now what else do we know from our function? We know that the asymptote equals to -2, but remember now our asymptote equals to what? Equals to q. So this means now the value of q is equals to -2. So we can now put what? The value of q on our function to say now this is b to the power of x minus 2. So we now have what? The value of q. So that means we will be able to find the value of b by substituting one of the points that we have on the equation. So remember, it can be any other point, but in this case, they gave us the x-intercept. So remember, the x-intercept, we have what? We have the value of x and the value of y. Okay, so the value of y is 0. So we can substitute now the value of x and y. So when we see y, we are going to put 0, because now that is the x-intercept. And then now the value of x is just going to be how much? It's going to be 3 here, and then we have -2 like that. Okay, so if we solve everything here, we're just going to put this 2 to the other side. So this is going to be +2, and then we have b to the power of 3. So if we want what? To find the value of b, we're just going to do what? We're going to do the cube root of what? The cube root of 2, because now we apply cube root on both sides so that this can cancel that. So we'll find that the value of b is just going to be the cube root of 2. So the cube root of 2 is just going to give us a 1.26. Okay, that will be the value of b. Okay, so you're not gonna get some problems, like they will give you problems where you're gonna get like whole numbers. Okay, for example, in this case, I just assumed the x-intercept and all stuff. But if this is what we get, we're gonna do what? We're gonna write our equation to say now our equation is going to look at what? It's going to be like y equals to b to the power of x plus q. Remember, when we find the equation, we neglect the value of a because we know the value of a just represents the side. Is our graph on top of our asymptote or the graph below the asymptote, okay? So now we can just substitute y equals to what? The value of b is 1.26 all to the power of x. And then now lastly, the value of q is -2. So this is how you will find what? The equation of the function. Okay, so like any other functions, we need to also know how to find what? A domain and a range. But before I do the domain and a range, I would like us to find an equation of a function that is a little bit not complicated like this one. So let's say, for example, now, we have a function here. So this function will look like this. We also have, again, our asymptote to be -2 here. And then now we can put what? We can put our graph to be like a decreasing function like this. So remember now, if it's a decreasing function like this, that means the value of b will be what? In between what? In between the, it's going to be in between, it's going to be in between 0 and 1, okay? So now let's assume now any point, we can assume any point. Let's assume the point is there, okay? And then this point here is having 2 coordinates. For example, we can say it is having a -2 is to 3, okay? So I can also see now, if I guess these values, we're also going to get some values of b that is not okay, and then some values of b that will actually make us to be confused. So it's fine. We can now neglect how to find the equation of this graph here. And then we also look at what? How to find the domain and the range of an exponential function. So a domain, remember now, a domain actually represents what? It represents the x interval. So if we look at this function of ours, which is an exponential function, so our domain, it has to do with what? With x interval. So if we look at all the x values here, you can draw the vertical lines to look at that. You see now, the graph is touching at every value of x. So now from -infinity to +infinity, the values of x will exist. So our domain is what? Our domain is going to be what? It's going to be where x is an element of real numbers. Or we can just represent it to say now, where x is from -infinity to +infinity. So that will be our domain, okay? But now when we talk about the range, remember now the range is actually what? It's actually the vertical interval, which has to do with y-axis. So now if we look at our graph here, our graph will touch any value of y except the values that are at 2 of y, or at -2, I mean, and then also below the -2. Below the -2 and at 2, we don't have the graph. But on top of 2 going upwards, we have the function. So we can just say now, the values of y will always be greater than -2, because now as the values of y are greater than -2, therefore we have the function there. If you put the horizontal line like that, you will see now your graph will touch at any point whereby we have the value of y as being greater than -2. And then you can also represent this to say now, okay, from the values of what? From -2 up to +infinity, we are having our function existing. So that will be the range of what? Of this function. Okay, so I know this exponential function, it can be a little bit confusing, but now what is important, when you plot, you just find the x and y intercept and then also the asymptote, and then you are able to plot. But now when you do what? When you find the equation, remember now when you find the equation, you always use the equation as y equals to b to the power of x plus q. And then you substitute the value of q. You use 1 point on the equation to find what? To find the value of b. So remember that point will give you the x-intercept, the x coordinate, and also the y coordinate, which you're going to substitute them on your equation. And then from that, you will be able to find your equation. Thank you very much.